I think this chapter is kind of straightforward. I guess we do have 3 formulas we need. You guys remember the formula we used a lot in this chapter?
Log one? Oh, the P1 plus R.
Call it exponential growth. Maybe. The growth. I think they just maybe call it the growth or decay formula. It depends whether the rate is a positive or negative. Do you guys remember the continuous interest, or not continuous, compound interest?
It's R over, and then you have T times amount of time, or how many times compounded.
Yeah, so if you put the number of times compounded there and right there. It's almost the same thing. And last but not least, we didn't use this a lot, so maybe you forgot it. It's just principal times e to the RT. That's for continuous interest. Yeah, we will need those 3.
That always sounds so painful.
It does.
That
Is it a cough or a sneeze?
I don't know.
Okay, number judging Lydia. Number 1, give a general expression for the value of a piece of property T years from now. If its current value is $150,000 and property values are increasing at a rate 9% per year. Okay, so something's worth $150,000 right now. It's supposed to increase 9% per year. So what formula are we going to use?
The
The first one. So the book uses function notation like A of t. We're starting with 150. And we're increasing by 9%. Remember to move the decimal twice. So 9% becomes 0.09 years. Or you could just put 1.09 in the parentheses. That's okay as well.
This one where that's So do we need to solve that, or is that the easy?
Can't solve it because we don't know how many years. Nothing to solve. Okay, on number 2, when you it's kind of easy because there's no letters. But let's try it without a calculator, so when we get to the letters, we don't panic and get it wrong. So on A, what do we do with the exponents on the top?
Add them together.
Add them. When you multiply like the same base, 2 times 2, you add their exponents. 5 plus negative 4 is
2 to the
1. So it's 2 to the 1 on top. When you divide by 2 to the negative 2, what do you do with those exponents? Subtract. So it's 1 minus negative 2, which is 3. So it's 2 to the 3rd. Okay, B, what do you guys think about B? A little bit weird. Do we just distribute the negative 1 exponent? No. If there's 2 different terms, you can't do it like that. You have to simplify inside the parentheses first. What's 5 to the negative 2 turn into?
Negative 25?
No.
1 over 25.
1 over 25. What's 5 to the 0 turn into? 1. So we have 1 and 1/25, or 25 times 1 plus 1. 26 25ths in the parentheses. And all that's to the negative 1. What's the negative 1 exponent do? Negative exponent is flip. So it's Okay, now, if I did put that one on the test, I'm not gonna count it wrong if you use your calculator. But if there are letters, you can't do that, so.
I'll find it.
I guess you, yeah, no, that wouldn't work. It might work, kind of. You could replace like an X with a 2 and then try to figure the answer out that way. Well, you guys know what we can do right here?
On the same base.
Or 2 to 7.
Yeah, change them to the same base. 4 is 2 to the what?
7.
2 squared. So what's 2 squared to the 6th? 2 to the 12th. So 4 to the 6 is 2 to the 12th. And then now that you have the same base, what can we do with the exponents? Subtract 12 minus negative 4, 16. And what do we do with that square root? You guys know what times what equals 2 to the 16th? Okay, the root here is an invisible 2. What's this in exponential form? Or, yeah, rational exponent form?
16 over 2.
16 over 2, which is what?
8.
8. You can just divide the power by the root. 16 divided by 2. 2 to the 8th times 2 to the 8th is 2 to the 16th, right? So anyway, it is 2 to the 8th. What might we do first on D?
Change the 9 to a 3.
Yeah, change them to the same base so we can fix their exponents. Actually, I kind of take that back. No, yeah, you can do it that way. You could have the numerator together first and then divide, but you can also kind of use, if these were both 3's, we could use like distribute the division. Got worse over the weekend, huh, Lydia? You cough a lot. I know. Okay, 9 to the negative 2 is what?
3 to the negative 4.
Okay, yeah, it's 3 squared, and then that to the negative 2, so you multiply. So this is 3 to the negative 4th. Okay, you could add these together and then divide the whole thing, but you could also use distributive property. What's 3 to the negative 3rd divided by 3 to the negative 3rd? 1. You could say negative 3 minus negative 3 is 0, and 3 to the 0 is 1. Plus negative 4 minus negative 3. Negative 1. So yeah, that is 3 to negative 1 is 1/3. So it's 1 1/3, or the book probably wrote 4/3. Okay, how did we solve the equations on number 3? 2 to the 6 minus x.
You set up the exponents like a normal equation.
Kind of. Same base. Okay, first we get the same base. 4 can turn into 2 to the what? 2 to the 2. And that 2 plus x is still out there. Now what can we do? What do we do with these exponents?
Distribute.
Yeah,
Multiply.
distribute, multiply. So that's like 4 plus 2x. If you multiply those both by 2. Now what? Yeah, if the bases are the same, to make these equal, the exponents need to be the same. 6 minus x equals 4 plus 2x. We're back to algebra 1. You guys would destroy algebra 1 if you took it now. If only. Mallory's kind of destroying it.
Is she in love with us like a bunch of freshmen?
Yeah. She doesn't like it.
But she stays really quiet.
Well, she stayed quiet in here, so that's but it's probably worth it for her. She's not like struggling at all.
I know.
I was thinking if she won like the class award for the highest, she probably wouldn't want me to give it to her. All right. This one, what do you guys think? Okay, what's the common base, girls? What's the common base here? 3. Okay, 27 is 3 to the what? 3 to the third. 9 is 3 squared. What are we going to do with this?
You just keep it as 1 out front.
Okay. Exponential form. This is 3 to the 3 halves. Exponential form is useful. And this would be 3 to the 4x. How do I combine these two guys? 3 times 3, we're adding.
4 over 2 is 2.
Yeah, the bases. Okay, so it's like 2 over 2 plus 3 over 2 is 5 over 2. It's like 3 to the 2.5, 3 to the 5 halves. Okay, now the exponents are equal. Dividing by 4 is like multiplying by 1/4, so it's x equals 5/8. You guys think you can do that one on the test?
No.
You said yeah or no? No.
Might.
Alright. A gallon milk cost $1.99 2 years ago. Now it costs $2.19. To the nearest percent, what has been the annual rate of increase in the cost? Okay, so it costs $1.99 now. In 2 years, after 2 years, it costs $2.19. What's the rate of increase?
199 and 1 plus r to 2
Yeah, so it's the
equals 2.
growth rate formula.
Yeah.
So it's 1 plus what?
R.
R, we don't know that. To the
2.
2, because it said 2 years pass. Then what? Equals 219. Alright. Now what do we do? Yes. Divide by $1.99. I'll just leave it like that for now. It's a mess. decimal, I guess. Whoops, I did it again. Okay, anyways, what do we do now?
Square root.
Since the whole left side is squared, we can clean that up by square rooting. Technically, this answer should be plus or minus over here, but a negative answer isn't going to make sense here, so you don't have to do that. Okay, this is some weird decimal. I'm just kind of leaving it alone now. But what would our last step be?
Subtract one.
Minus 1. Solve for r. And
4.9%.
so you got like 0.049, which translates to about 4.9%. Why are girls playing chess?
We love chess, okay? It's so fun.
From study home?
Yeah,
Who taught you?
Will. And so I bought one.
And
And
Will's
we have
friends
it at
with
my house.
us.
Yeah, Will loves us.
I wish I loved us.
He literally just pulls up a chair. He doesn't even.
He just, yeah.
He just pulls up a chair.
Then he talks to us.
He
Interesting.
tried to lick me, Mr. Jordan.
I know, you already told me.
And then he hit my hand the other day.
I think he had a crush on you, yeah.
That's
Oh,
not.
you're such a cute couple.
It's not
Are
funny.
you guys? No, I'm right.
What would you say, Mr. Jordan?
Gonna go to prom.
That'd be great.
Honestly,
When I go to prom, just to see that.
Yes. Isa's brother Aiden asked me to prom.
Was that like
Yes.
last year he did?
Was that last year
The year he was in our class.
Oh yeah, he didn't really come here last year.
When he was watching his anime.
I'm surprised.
Remember when Isa asked me?
Yeah, when Isa went to his room and asked him if he liked
And she videoed.
and said it was me.
I see her walking her dogs every day barefoot.
So like she would walk around with it.
All right.
Is she barefoot? No.
Are you doing fire?
Yeah, man. I don't think we ever did that, but
No,
I can't.
Graphs this entire time.
After school.
Not this chapter. No,
Let's not do it, Mr. Jordan.
it's not hard.
The graph just might be the file.
A graph paper for one problem.
Well, you wouldn't really have to get graph paper out there.
Yours are short.
Okay, that's fine. Number 7.
Oh, yeah.
Okay, why don't you guys try this one on your own? We'll see if you get it right. Suppose $1,500 is invested at an 8.5% rate. After 18 months of interest is compounded quarterly A or continuously B. So 18 months is how many years?
1 year and 6 months.
Year and a half.
1.5 years. It's, yeah, 12 months is 1 year, so, and the extra 6 months is half a year, so it's like 1.5 years.
And then continuously is like every.
E.
To the RT.
Okay.
That's it. It's really short.
Got it.
should have plugged in. Since we're talking about money, you can just round it to the. Oh, it's not number 5 either.
Wait, where'd you get the 1.5 years?
1.5 years.
My socks. Oh yeah, I found it. Like one sock, like the one like orange. Yeah, yeah, like. And also this stuff in the pants.
Okay, we did these on the homework, but I don't know, they're kind of hard to explain, and plus it just says this, so you can kind of cheat and use your calculator. Basically, you know how this is like base 10 right here when they don't say anything? If the decimal has moved back 1, that's like multiplying by 10 to the negative 1. So this is going to go down 1. So you would subtract 1 for that. I don't really care, you can use your calculator. Doesn't seem like a skill you would necessarily need. B, the decimal is, how far did the decimal move? 2 to the right, which means it got 2 bigger. So that means the exponent should get 2 bigger. So it's 3.3979. There's one more. 0.0, curveball. Uh, 0.04.
What?
This is 1/25. So it would make the next exponent negative, I guess. Like that was positive 25. This is equal to 1/25. So I think the exponent would just turn negative on this one. And flip it. So in log functions, the exponent's kind of the answer out to the right there. Anyways. You can just use your calculator, I don't care. Number 9. Let's try these without a calculator. So, on A it says log base 2 of 8. What is that as an exponential equation? We probably should have started with that. I don't know why they didn't do number 1 like that. It's 2, what? What's it as an exponential equation?
2 to the 8?
No,
8 to the 2?
no,
2 to the 10?
no. Yes.
2 right equals
2 to the what? 2 to the x equals 8. Let's see, this is number 9. Alright? Yeah. Okay, 2 to the what equals 8? What's the answer to that?
3.
3. 2 to the third is 8. 2 times 2 times 2 is 8. So on B, they're kind of going backwards. It's 8 to the what equals 2.
1/3.
Yeah, it's the cubed root of 8 is 2, or 8 to the 1/3. It's 2. Sam, you did it. You were the best. All right. C. If you look at the exponent, 4 to the what equals 64? You guys know that one? For just the exponent. 4 to the what equals 64? Third. Yeah, 4 times 4 is 16, times another 4 would be 64. So the exponent is a 3, so that problem really turns into 2 to the third, which is 8.
It seems like a 2-day assignment.
You are incorrect, sir. We're almost done.
Oh, this section.
All right. Log 2y equals 2 log 2 2x. Okay, on these log equal log function or equations, it's kind of like number 3. You want to just kind of get the two logs equal to each other. So what can we do with this 2 out in front? Yeah, it can move to the exponent. So we got log base 2y equals log base 2 of 2x squared.
So y equals 2x squared.
Yeah. Can't really solve completely, you just simplify it. What's 2x squared simplify to though? 2x times 2x is, 2 times 2 is 4, x times x is x squared. You just, when it's one term, you just square everything in the term. 2 times 2, x times x. I think that was Eddie. Yeah. Log base 2y equals log base 2. What? Oh, 2 plus. Oh. I don't think we did one of these. Will I put it on the test? Maybe. I'll think about it. Well. Here's the thing. This is tricky. That 2 we can turn into a log. So that we can like combine these two. Why am I not just putting it up here as an exponent this time?
Means no multiply.
It's not a multiply thing. How can I turn 2 into a log base 2? Okay. 2 to the 2 should equal 4, right? So log base 2 of 4, this is equal to 2. Because it means 2 to the what equals 4. Now that it's a log base 2, you guys remember the rule? How do these two go together? Yeah, 4 times x. If you're adding logs, you can multiply. So it's log base 2 4. So y must equal I probably won't put that on there. Maybe I'll make it a bonus. That sounds like a good bonus question. Number 11. Okay, on 11 they want us to break the logs apart. Alright, there's so much to do here. Let's, what can we do with this root here? This cube root?
Then the exponential form.
Yeah, this would be m to the what? 2/3. It'll probably clear some stuff up. M to the 2/3 over n to the 1/3. Okay, to break it apart, when you're dividing things, what's that? How can we write that in log form if these are divided? Subtract. So it's log base b of m to the 2/3 minus log base b of n to the 1/3. There's one more thing to do. They want it to just say like log of m minus log of n, so they don't want these exponents up here. So we can move them back to the front. Log base, nope, wrong one. Log base b, m squared n cubed. This one's easier for some reason.
Wouldn't this just be adding them together?
Yeah.
Okay.
Okay, yeah, when you have the numbers multiplied together, that would be like addition. So it's log base b of n squared plus log base b of m cubed. And then you move the exponents up to the front.
Did you switch it around for the
Did I?
variables on B,
Oh, what?
on the random one? In shouldn't be,
Yeah, it's.
Yeah.
I switched the m and the n around.
yeah,
Okay.
It's
Alright. Well, we're supposed to solve this equation. Any ideas?
Put it all together.
Yeah, how would those go together?
Log x squared minus 4x.
Okay, yeah, x times x minus 4, you multiply that together. And then, now what?
you run to exponential.
Yeah, if it's, you're solving an equation and it's not just like plug it in the calculator kind, then a log equation, usually you have to change it into exponential form. So what's this in exponential form? 5 to the 1
equals x minus x minus 1.
5 to the 1 is 5. And this is x squared minus 4x. How do we solve quadratic equations? No, no. Move it to one side and factor it. Come on now. Algebra 2 can do this.
Come on, man.
Problem,
Minus 1 plus 5.
You can either factor or quadratic formula. So, what multiplies into -5, that adds up to -4.
Minus 1 plus 5. Wait. Yeah. No? Minus 5 plus 1.
x values make these factors equal to 0?
Negative 1 and 5.
Um, the -1 doesn't work when you plug it back in because 5 to the y equals -1. You can't make 5 to any power equal negative, so the -1 kind of gets thrown out. But the 5 works. Alright, 14. Last, and possibly one of the easiest. Everybody better get this one right in the test.
Okay. Linear hundred.
What?
You made eye contact.
How'd you do that?
Allison, do you know how to set this one up?
Isn't just log to, wait, log ACB.
Yeah.
5
Yeah,
and then 8.
good job. It probably says rounded, yeah, the hundredths place, the second decimal place. 1.29, yeah.